My name is Tysen. I'm also from the Nonlinear Dynamics and Control Lab, same place where Rissa works. And this summer I got to work on the robotic fish project. And what's interesting about the robotic fish project is it actually covers a lot of really broad objectives, so it's kind of difficult to talk about any one of them in particular without hitting on all of them. So one of the main focuses of our lab is the control and operation of unmanned aerial vehicles, or UAVs. And I'm here to show you a little bit about how we can use our fish to help support our research of UAVs, even though an underwater robot might not seem all that much like a plane in very many ways. So this is an old picture that I dug up from the annals of our research. Nathan, do you know how old this picture is?
Probably 7 or 8 years old now.
Yeah, so I'm willing to bet this was taken when I was in middle school. So if you might notice the very front of the fish here. Oh, there's already. This flat face here doesn't look very fish-like. It's notably not especially hydrodynamic either, I would imagine. But despite its boxy appearance, it's very clearly a fish. It's based on the way fish swim, but it's not quite as simple as just copying what the fish looks like and hoping your robot does the same thing. There's actually a lot of really complicated mathematics involved in modeling the system. And unfortunately, I couldn't tell you very much about them because they're past. They happened a long time ago. I'll probably have it over my head anyway. But it's actually modeled after, very similar to a tuna. Tuna has a very firm, strong body with a powerful tail, and this fish is the same way. Its body is very flexible at all, and has a powerful tail it uses to swim. But it swims in much the same way as a fish does. It flaps its tail back and forth to move forward in the water, and uses these fins on the side to move up and down. And our next slide here is actually a video of a more recent version of the fish. This is more or less what they look like right now. And at this point, this is also before my time, but this is a video of an experiment we did that had 3 fish all working in tandem to track a toy shark. And this is how we use our fish to simulate UAVs. So what these fish are good for is we take 3 fish and try operating them at the same time, sometimes with different objectives, sometimes all with the same objective. But the idea is that they all can work in the same area on a similar goal without interfering with each other. And that's what's really interesting about these fish, is we can simulate doing the same thing that we would want to do on aircraft using fish. This is actually a video. If I can get it to work. Quick time not available. Never mind. If you go to the internet and look up UW robot fish, this will show up pretty quickly. It's a common video. And one thing our fish do in the pool, actually, I would have showed you in the video later on, but what we do is they aren't equipped with a whole lot of their own sensors. They have an accelerometer that records their roll and a depth sensor, but in order to tell them where they are in the pool, we actually have a camera system set up in the 4 corners of the pool that track the fish where they are very, very closely, and where the shark was at the time, and tell that system tells the fish where they are and where the other obstacles are. So what's interesting about these is that the shark in the video is not following a predetermined path. Somebody is driving it around in all kinds of different patterns, and the fish are using the data from this camera system to track where the shark is and follow the shark based on their own algorithms. They're generating their own controls and paths in real time. They're not pre-recorded and just thrown in the pool. They're actively trying to find out where the shark is and follow it as best they can. So the fish are actually an old project. The fish themselves are left over from bio-inspired research project. We do a lot of other bio-inspired projects in our lab, like the quadrotor is taking advantage of the moth abdomen to make a pendulum that simulates it. The fish is also a bio-inspired research program. And what's interesting about bio-inspired research is it's not as simple as taking an animal and looking how it moves and just copying what the animal does. It's about really investigating what it is about the animal's means of movement that make it good at moving, and then recreating only those parts. Because for good reason, our fish doesn't smell like a fish. It's not covered in scales. It's not slimy. We did a very, very careful analysis of what makes a fish good at swimming and tried to recreate that using what kind of systems we have. And so these are some other examples of bio-inspired research. We actually saw a video earlier today. I think it was a James presentation of this particular platform is based on bees. It's a robotic bee that developed by Harvard, I think. And they model bee flight and recreate a robot using the same thing. Another one you may have actually seen before is called Big Dog. It's a big robot based on it looks like a dog. It's really capable of moving across really uneven terrain if you look underneath its feet, you can see these cinder blocks kind of stacked randomly. They're testing how well it can deal with uneven terrain, and how it can learn to cross rough areas. And this one was my favorite, looking around at other bio-inspired research being done. It looks a lot like one of our fish. It's actually designed by Delft University in the Netherlands.